Alright, so in this video I'm going to just go over logarithmic differentiation. It's a way to take the derivative of a function without having to go through like the quotient rule and stuff, so you use natural logs to split it up. And so this video is just going to be this example. It's a pretty thorough example, so hopefully it should cover a big part of what you would see in a logarithmic differentiation problem. So here we have find dy dx of y equals x minus 2 squared divided by the square root of x squared plus 1. First thing we're going to do is just take the natural log of both sides. Now when you take the natural log of this y, it actually becomes treated like a u, so it's going to be y prime over y equals, and now if you apply your properties of logs to this side of the equation, then you can, since it's division, you can split it up into subtraction. So the natural log of x minus 2 squared, that's the top, minus the natural log of the bottom, and I'm just going to rewrite it as x squared plus 1 to the 1/2. That's the same thing as the square root. Bring down our y prime over y. Essentially what we're going to be doing is we're going to be solving for y prime. So we're going to have this y prime equals and then some sort of function with just x's in it. If you go ahead and use your other properties of logs with the power, you can bring the exponent to the front. So there's a property of logarithms where you bring the exponent in front of the log. So that's going to equal 2 times the natural log of x minus 2 minus 1/2 natural log of x squared plus 1. Now what we're going to do is we're going to use our we're going to complete this in two parts, but since we don't have just the natural log of x, we're going to have to treat this inside the parentheses as a u. So remember that when you treat something as a u, when treating something as a u, and you've got that natural log in front of it, you use u prime over u. So like here, I'm just going to bring down the 2, that 2 right there, and now in this case we're going to treat this part right here as our u. So if I have u equals x minus 2, then the derivative of that, du dx, is just equal to 1. So it's going to be 2 times u prime, in this case is 1, divided by u. U in this case is x minus 2. And so we got rid of our natural log there. Now minus 1/2. Just bring that down. Now for this one, our u is going to be x squared plus 1. So if I go over here and do side work, u equals x squared plus 1. du dx, the derivative will be equal to 2x. So this is going to be multiplied by, once again, u prime goes on top. In this case, that's 2x over u. U in this case is x squared plus 1. This 2 right here and this 2 can cancel out. So if you bring down all of this, y prime over y equals 2 over x minus 2 minus x over x squared plus 1. And so right now we got rid of our natural logs. So now what we're going to do is remember that we want to get y prime by itself. So in order to do that, we're going to multiply both sides by y. So that would cancel those out. And now what I'm going to do in the next step is for y, I'm going to substitute in our original equation, because here we have y equals this right here, a function that's in terms of x, and that's what we want to get, is we want to get just x's. So we have y prime equals 2 over x minus 2 minus x over x squared plus 1 times, and now here's going to be where we substitute in our original function for y, times x minus 2 squared all over, and once again I'm just going to change the denominator to a fractional exponent. Now it's just a matter of simplifying. So I'm going to deal with this first factor, and what I'm going to do is get a common denominator of x minus 2 x squared plus 1. So this term over here is missing an x squared plus 1, so I'm going to multiply it by x squared plus 1. This term over here is missing an x minus 2, so I'm going to multiply that by x minus 2. So that's going to be 2x squared plus 2 minus x squared and then it'll be negative 2x, but we're going to have to distribute this negative, so it'll be actually plus 2x all over x minus 2 x squared plus 1. So there I just got a common denominator and I did all of my distributing. And we still have this fraction over here on the right. You can, if you look here, you can see that this x minus 2 can cancel out with one of the x minus 2's up here. So you can cross that out, and you can cross the 2 out. This just becomes x minus 2 to the first. Combine like terms right here, 2x squared minus x squared. So I'm going to rearrange it a little bit and bring the 2x into the middle. So x squared plus 2x plus 2 all over x squared plus 1 times x minus 2 over squared plus 1 to the 1/2. And finally, if you just distribute across, you can get y prime equals, I'm just going to leave the numerator in factored form rather than distributing it all out all over. Remember that this is to the first, so when you multiply exponents, you just add them. So 1 plus 1/2 is 3 halves. So x squared plus 1 to the 3 halves. And there is your derivative. So there's logarithmic differentiation. Hopefully all the steps made sense and I didn't miss anything that I should have said. But yeah.